We look at WASSCE Private Candidate 2007 Essay Question 3b, and it's under bearings. P, Q, R are 3 points on a horizontal plane. Q is on a bearing of 65 degrees from P, and R is on a bearing of 335 degrees from P. If the length of PQ is 12 meters and the length of RQ is 20 meters, find the length of RP. Before we start, if today is your first time on my students class channel, don't forget to subscribe and click the notification button so that you'll be promptly informed anytime we upload a new video. And hey, one more thing, click the like button so that the video can reach a lot of people. Thank you. Now let's continue. So let me gather the data here. First, we have Q on a bearing of 65 from P. So Q is on a bearing of 65 from P. From P means we will begin from P and go to Q. So the vector is vector PQ. So from P to Q, we have a bearing of 65 degrees, and that is 065 degrees. And of course, we are told that the distance from P to Q is 12 meters. So let us also put that one here. So that is magnitude and bearing. And we also have R is on the bearing of 335 degrees from P. So from P to R, so we have PR2, vector PR. R is on a bearing of 335 degrees. And let us see the distance from R to P, or P to R. Do we have it here? Alright, the distance from R to P is not known, but we know the distance from R to Q. So let's say from P to R is say X kilometers. And of course, the distance from R to P, so R to Q is 20 meters. So we asked to find the distance from R to P, which is the same as the distance from P to R. That is distance from R to P. The magnitude of RP is the same as the magnitude of PR. Alright, let us sketch our diagram and look at how we solve this question here. So let me put the point P here, and from the point P, let me draw my cardinal points, the north, south, east, and west, or the y-axis and the x-axis here. So that is bearing, and bearing we measure from the geographic north, and that is the south. Here is the east, and here is the west. And these are the figures that we have. We have here to be 0 degree, and here is 90 degrees. Here is 180 degrees. The west is 270 degrees. Then we come back to 360 degrees. So we measure in a clockwise fashion. All right. So if I have from P, I'm going to Q, and the bearing is 65 degrees, then that means that I have to measure from the north here. I have to measure from the north, and from north to east, this is called the first quadrant. So between north and east, the angle here is 90 degrees. So I'm going to find an angle which is 65 degrees here. So I move from P to Q. So that is the point Q. And I'm told that the distance from P to Q is 12 meters. So here is 12 meters. And I'm also told that the bearing of Q from P, so from P to Q here, the bearing, that is the angle here, is 65 degrees. So I have 65 here. So that is what I have here. This is the first thing I have to do here. Then it says that from P to R2, because it said, and R is on the bearing of 335 degrees from P. So on the bearing of 335 from P to R. So from here, it begins here 0. From the same P, here is 90. And here is 180, 270. So 270 plus what will I get? 335. 270 plus what will I get? 335. So x is equal to 335 minus 270. And that is also 65. So I will check from here. 0, 90, 180, 270, and I'll add 65 to this so that I'll get 335. So the bearing here is, or the angle here is 65 degrees. Because for the bearing, I have to check from the north here, 90, 180, 272 here, and that is 335. So the whole of this angle here, the bearing is 335 degrees. So from P to R, I have the point R also here. And the distance from P to R is not known, so let me say it is X kilometers here. Now the question says, what is the magnitude of RP? That is the distance from R to P. But I'm giving R to Q. R to Q is 20 meters here. So let me connect R to Q too. So I'll connect R to Q here. Okay. So I know R to Q, and that is 20 meters. All right, let me look at what I have here. Now this is the y-axis, and the angle here is 65. Now the entire angle here is 90. This is the second quadrant. The entire angle here is 90, and if here is 65, then what is left here? If here is 65, what will be left here will be 25. So the angle here, the small angle here, is 25. So if here is 25 and here is 65, then what is the entire angle here? The entire angle here is 65 plus 25, and that is 90 degrees. So the entire angle here is 90, and that makes this a right angle. And if you have a triangle where one of the interior angles is a 90 degrees angle or a right angle, then it means the triangle is a right angle triangle. In other words, triangle PRQ or PQR is a right angle triangle. So that is to say, I can apply Pythagoras theorem. So by Pythagoras theorem states that for a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, and the hypotenuse is the longest side, and of course it is the side that always faces the 90 degrees angle. In this diagram, the hypotenuse is the side RQ or QR, so I'm going to write RQ squared is equal to the side RP squared plus the side PQ or QP squared. So I'm finding RP from the question. I'm finding RP, so that is to say I'll make RP the subject. So let me leave RP here and subtract PQ squared from both sides of the equal sign. In other words, I want to move the PQ squared to the side of the equal sign. So I'm going to have RQ squared already here, and there will be a change of sign here for PQ squared, so it's going to be negative PQ squared. Alright, so let me rewrite this again by writing the RP first. So RP squared, the right side first, then let me add the left side, is equal to RQ squared minus PQ squared. Alright, so what is RQ? RQ is the length 20. So 20 squared, and PQ is the length 12. So you have 12 squared. So 20 squared is 400. And 12 squared is 144. So let's see what happens here when we subtract 144 from 200. So 144 from 200, that is going to be 256. So the length RP squared is 256. And if we want to find RP but not RP squared, then we have to get rid of the square sign. And to do that, we take square roots of the RP squared. And because there is an equation, whatever we do to the left side of the equation, we have to do the same thing to the right side of the equation. In other words, we take square root of the right side too. So this square root will cancel the squared, and this implies that we will have the magnitude or the length of RP to be equal to 16. And of course, we are measuring in meters, so we have 16 meters. So that is to say, the length RP is 16 meters.